Okay. Um, for many reasons, I'm just going to read what this says. For many reasons that future math classes will explain, there's one base that's used more frequently than any other base, and it's the number that we denote with the letter E. Very similar to pi, and its value is approximately 2.71828. Now, I enjoy doing this. Um, I went to one conference one time, and the math teacher showed me a way of remembering E out to, and it was 15 decimal places. And he said, all you need to know is remember that Andrew Jackson was the seventh president of the United States, elected in 1828 for 2 terms, and he had a favorite hat in the shape of a triangle whose angles were 45, 90, 45. Now, it is true he was the seventh president elected in 1828. Obviously, 1832 would have been the next time he was elected president. And I don't know if he ever wore a triangular hat, but that is E out to 15 decimal places. All you ever really need is a couple of decimal places. So 2.72, 2.718, or something like that would be fine. Even 2.7 will get you through most of the problems. It's even easier than that because our calculators have the E function built in, just like pi. And if you're still typing 3.14 into the calculator instead of using the pi button, start changing towards using the pi button. So like pi, E is an irrational number, meaning it never repeats and it never ends. It goes on forever. Since E is larger than 1, its graph is similar to every other exponential function whose base is greater than 1. So you need to be able to quickly construct a graph of E to the x whenever you need to. So again, its y-intercept is going to be 1. It then goes through the point 1e. Okay, that's this point up here. Desmos wouldn't put the e in there, so they had to call it 2.7. It's got a horizontal asymptote as x approaches negative infinity. It goes off to infinity as x approaches positive infinity. Always increasing, always continuous. All right, when you're using decimals, if you want to graph it, just use the E on the keyboard. On the TI calculators, there's 2 options, the most common being you're going to see a button, and this is our first introduction. This isn't a lowercase l. Remember, a lowercase l and then capital I look exactly the same, okay? It's not. This ln here stands for the natural logarithm. That is a lowercase l. And the reason I say that is I get people writing capital I N all the time, and it's not that way. But in right above the ln, you should see a little e to the x button on your calculator if you have a TI, and that's what we're going to use. So you hit the second button followed by the ln, and you're going to see an e to the exponent. All right, we're not going to do so much with it today. We're going to continue after we talk about logarithmic functions. We'll bring it together, and we'll be using e quite a bit. And when you get into calculus and beyond, it's used even more. So the last couple of examples I want to do has you writing an exponential function given some pieces of information. So if you remember way back in Algebra 1, I gave you 2 points, or your algebra teacher gave you 2 points, and you had to get a line through that. We did a little bit with quadratics, giving you some points and finding a quadratic that goes through that. Now we're going to take the same idea with exponential functions. So again, an exponential function in this form that goes through this point and this point. So first of all, this right here is a y-intercept. That's the starting value. So just from this fact, I know my a value is 3. So my function now looks like 3 times b to the x. Then I take this x value and this y value. I plug them in. And now I solve this equation for b. So I'm going to start by dividing by 3. So I get 16 equals b to the 4th power. And then we take the 4th root of both sides. And I get b is equal to 2. So my function is 3 times 2 to the x. Okay. If you need to go back and look at that again, feel free to do that. This one's tougher because it gives you still 2 points, okay? The points are negative 4.515 and 559, but neither of those are the y-intercept. And so how do you do it? If I'm looking for f of x equals a times b to the x. Well, if I plug in x and y, I'm still going to have these two unknown values. So the strategy is one that you may not necessarily consider. So here's what we're going to do. Let's take this point and plug it in. So I get 15, that's f of x, equals a times b to the negative 4.5. And then over here, 59 equals a times b to the fifth. So first thought, your question might be, how do we do it? Can I solve for one number and plug it in? So can I solve for a and then substitute it in over here and go like that? Yeah, you could. Okay. And I've had students in the past who want to do it. Generally speaking, though, the way that most of the time it's taught is they merge these two by dividing one equation by the other. So let me show you what I would do here. I would take the left side of this equation and divide it by the left side of this equation. Take the right side of this equation and divide it by the right side of this equation. Now again, since these two things are equal and these two things are equal, we can do that process. So now the left side, still get 59 over 15. But look at this. On the right side, and if you need to verify this, if I have 3x over 3y, we can cancel those 3's. So I'm going to do the same thing here. I can cancel those a's. Now I have a quotient of powers, so I get b to the 5 minus negative 4.5, which is 9.5, or 19 halves. So now the question is, how do you take the 19 half root of this, which seems really strange and bizarre, and it should be. But remember, all I need to do is get rid of this power. And I can get rid of this power by multiplying it by its reciprocal. So to do that, what we're going to do is I'm going to take both sides of this equation and raise it to the power that is the reciprocal. Again, why? Because a power to a power we multiply, and these numbers would cancel. So I get b is equal to 59 over 15 to the 2/19 power, which is about 1 point, and I'm going to hang on to most of the decimal places here. At this point in time, I would probably tell you to store this value into the calculator because this does not end here. This would just continue on and on. But for now, that'll be sufficient. All right, so my function now is, I'm going to write it, a times 1.1550649 to the x. Now I have three unknowns. Take either of these points. I'm going to take the 559 because it avoids the decimal. 59 goes in for f of x. To the fifth power. And since this is multiplication here, we just divide by that value. And I get a, comes out to be 28.69591231. So now I have a and I have b. So f of x comes out to be 28.69591231 times 1.1550649 to the x power. I apologize for the messiness there. The last part of the question, it wants f of 8 to the nearest hundredth. So this is where storing the values. And when I get back, I'll show you some strategies about how to store values and to write them. This goes right into a calculator, rounded to 2 decimal places, should give you 90.92. And I would encourage you to do all of these steps on your own. Verify these calculations, make sure that they're true. And this will take you pretty much through everything that's in the Delta Math exercises. So try to do those. I anticipate being back on Monday, so we'll be able to go through any questions on rational or exponential functions before we move on to logarithmic. Alrighty, that's it for this. Have a great one, everybody.